morning, everyone, and welcome to our first online lesson. I hope that you guys are all doing well at home, and I hope that you guys are doing well after we just finished our Chapter 7 test. We're getting ready to move into Chapter 8, which is talking about polynomials and factoring. And today we're going to cover our first lesson in Chapter 8, which is adding and subtracting polynomials. And we're going to learn a lot about what a polynomial is. So for this lesson today, you're going to need a few things in order to be able to do well today. First thing you're going to need is some paper. You need something to write your notes on and keep them all together for Chapter 8. So that way you have materials to study for when you're taking your quizzes, and you have materials to prepare you for your tests, and you also have materials to help you with your homework. You're going to need a pencil, so that way you can write down your good notes. A basic calculator for today, and if you don't have one, you can use one on your cell phone or from your computer/laptop. You will also need the end of the lesson, homework 61, which is lesson 8.1a, adding and subtracting polynomials, and this will be located in the yellow folder that you will pick up from the school. So we're going to go ahead and we are going to get started. All right, the first thing we have, you'll notice, is some vocabulary. We have 4 vocabulary words, and you'll notice that there is some spacing in between. The spacing is important when you copy your vocabulary down, that you leave room to put examples of what each of these vocabulary words are talking about. So what you'll need to do through this lesson as we're going on is you can pause the video at any point in time to take a moment and write down the vocabulary words. And then if you need more time to copy down the definitions, or you need to replay and hear something that you thought you didn't understand and you need to hear it one more time, please feel free to stop, rewind, and go back and play the video again. So take a moment, pause your video, write down your 4 vocabulary terms and definitions, and leave space in between each so that you will have room to write down the definition. Once you have done this, you're going to go ahead and press the play button again, and you'll jump right into me explaining what each of these vocabulary words mean. All right, so vocabulary word number 1 is a monomial, which is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So whole numbers means not fractions, not decimals, whole numbers. Not negative numbers, but positive numbers for our exponents. So in a monomial, we're going to give an example of each of the various types. We'll first start out by looking at a real number. So a real number would be, say, 4. That is a real number. It could be a variable. So an individual variable could be x. Or it could be a product of a real number and one or more variables with whole number exponents. So we're going to do a real number and one variable with positive exponents, and then a real number with more than one variable with whole number exponents. So we'll do 5 x to the 3rd, and this is a whole number, 5, a variable x with an exponent of 3, which is a whole number. Then we'll move on to another one. We'll do -8, and then we're going to do x to the 2nd and y to the 4th. So now we have more than one variable, and they have 2 different exponents. They have a 2 and a 4. Now we're going to talk about the degree of a monomial. The degree of a monomial is the sum of the exponents of its variable. Remember, sum means to add. So we're going to be adding up these variables' exponents. Not the coefficients, just the exponents. So for instance, if we have 2x to the 3rd and y, we would take our 2 exponents, which are 3, and our understood 1 for our y. When there's a variable with no exponent, it is an understood 1. So we're going to add 3 plus 1, creating 4, making this monomial have a degree of 4. If we have things that have other ones, let's do, for instance, we're going to do 8, x to the 5th, y to the 4th. We will take our two exponents, 5 and 4, and we will add them together. 5 plus 4 is 9, which means we have a degree of 9. A polynomial is either a single monomial or a sum or difference. We're going to add that in there, or difference of monomials, because we want to understand that sometimes we're adding our monomials, sometimes we're subtracting them. Sometimes in a polynomial you're doing adding and subtracting. So we're going to combine them all together. So we'll show you an example of what a polynomial could be. It could be 3x plus 2y. That is a polynomial. We have one monomial being added to a second monomial. We could have 2ab minus 6ac. So now here we have one monomial minusing a second monomial. Or we can have 3 plus 2x minus 4y. Here we have a polynomial because this is a sum of monomials or difference. So one monomial being added to a second and minusing out our third. So these are all examples of polynomials. Vocabulary number 4, which is standard form of a polynomial. This means that we take the degrees of the monomial terms and we put them in order from the highest degree to the lowest degree. So we'll give you an example of one and then I'll explain it as we see. Suppose we have 8x to the third plus 4x squared minus 2x plus 7. We can see that our degree of the first term is 3. The second one is 2. The third one is an understood 1. And we have no exponent here, so that's a degree of 0. Sometimes you may not have everything. You may not have a 3, a 2, and a 1 degree. It might go straight from x to the 4th minus x plus 8. But we still went down from highest degree of 4 to the next lowest degree, which would be 1, to the next lowest degree, which would be 0. So then 4, then 1, and then finally here, no degree. All right, we're going to move on. We have 3 problems, and we're going to look at these. In each of these, we're going to explain how you find the degree of our 3 examples. So looking at our first one, we have the coefficient of 5 and the variable x. Our x, you do not see an actual exponent. In this case, it means it has an understood exponent of 1. That means my degree, since it's all based on the exponent of the variables, is a degree of 1. For our second guy, we have our coefficient of 6, our first variable with a degree of 3, our second variable with a degree of 2. To find the degree, remember it's the sum of the exponents. So we take our first exponent, which is 3, and we add it to our second exponent, which is 2. 3 plus 2 makes 5. So this is a degree of 5. For our final example, we have the constant form. We have no variables, so therefore we have no numbers to add. If we have no numbers, that means this is an understood degree of 0. There are no variables. 0 variables, 0 degree. Now we're going to give you a moment in time to try each of these problems in practice time. We have 3 problems. So for practice time, what I want you to do is to attempt to solve each of these problems on your own. You will pause the video, take a moment, and solve your problems. At the end of when you feel like you have answered all your problems and you want to check your work, you'll resume the video again, and I will have explained how to solve each of the problems. Either you can solve one and resume, you can do all three and then resume. The total choice is up to you. So this time I'm going to go ahead and start explaining practice problem number 1, which we are going to be doing finding the degree of the monomials. So for the first one, we have a coefficient of 3 and a variable x. Since we do not see an exponent, that exponent is an understood 1, making this a degree of 1. Hopefully you did a good job. Number 2, we have a coefficient of 8, a variable of a raised to the third power. I only have one variable, so I only have to look at the single exponent of that variable, which is 3, making this a degree of 3. For a third one, we have a coefficient of 2. We have the variable b to the 8th power, the variable c to the 2nd power. To define the degree of a monomial, remember, it is the sum of the exponents. So my first exponent is 8. My second exponent is 2. Sum means to add. 8 plus 2 is 10. So this would be a degree of 10. I hope you guys got them all right. If you did, give yourself a whoop whoop in the house and a pat on the back. Here we go. If not, make some notes and text me through remind at the end of the lesson. All right, example number 2 will be adding and subtracting monomials. So again, monomials are single individual terms that are separated by adding signs or subtracting signs. So with our monomials, in order to add or subtract them, we're going to use the concept we used at the beginning of Algebra 1, which means they have to have the same variable raised to the same power, which means we want them to be like identical twins. So in this first one, this guy has an x squared, and this one has an x squared, which makes those x squareds identical twins. The only thing that's different about them are their coefficients. One is a 3 and one is a 5. 3x squared means I have 1x squared plus 1x squared plus 1x squared, making 3x squared. 5x squared means we have 1x squared plus 1x squared plus 1x squared plus 1x squared plus 1x squared, which means I have 5x squareds being added together. Then the sign in between says I'm going to take what I have over here and add it to what I have over here. So here I have 3 of these. Here I have 5 of these. 3 plus 5 makes 8. And what I'm adding are x squared. They're all x squareds. So I have 8x squareds. We never mess with this exponent unless we're multiplying or dividing. Since we are just adding, we keep the variable with the same exponent. This component stays just the same. It does not change. This is what will change based upon whether we're adding or subtracting. Looking at our second part of our example, here we want to break this guy down. It's very clear that the coefficient to this guy is a 4, but we don't see a coefficient here. Because if you don't see a coefficient, it is an understood 1. We look at the back end and notice that these guys right here are identical twins. They're both x to the third power y. So this would mean I'd have 4 of those. I'd have 4 x to the third y. So 1, 2, 3, 4, creating me 4 of these guys. There's my 4. Then I have 1 x to the third y on the back end. So 1. The sign in between is to minus, so I'm going to minus. So I'll take 4 of these x cubed y's, 4x cubed y's, and I will minus 1 of those away from there. So 4 minus 1 would leave me with 3x cubed y. Again, I did not mess with the exponents. You notice this part stayed the same. The only part that changed was the coefficient, and it changed based upon whether I am adding or I am subtracting. In our case, we were subtracting. So 4 minus 1 is 3. Final answer, 3x cubed y. So now we're going to give you 4 more problems to try. Just like the previous practice prime problems, we want you to try the problems, pause the video, answer them, and then check to make sure you have the answers correct. So here we go for the explanation to problem number 1. We have identical twins of p squared. We take our coefficient of 12, and we're going to add it to our coefficient of 8. 12 plus 8 is 20, creating me 20 p squared. We have identical twins again of m cubed, n cubed, and m cubed, n cubed. We'll take our coefficient of 2 and our coefficient of 9, and we will add 2 plus 9, making 11. So 11, m cubed, n cubed. For number 3, we have identical twins of b to the 4th and w to the 3rd. Take the coefficient 30 and the coefficient 12 and do the sign in the middle which says subtract. 30 take away 12 is 18, creating 18 b to the 4th w cubed. Our final one, they notice they have identical twins of x squared, coefficient of 7, coefficient of 2. Do the sign and operation in the middle, which is minus. 7 minus 2 is 5. So I have 5x squared. Hopefully everyone did really well. If you got them all right, give yourself a whoop whoop in the house and a pat on the back. If not, make some notes and text me through Remind, and I'll be more than glad to answer your question. We're going to move on to example number 3, which is classifying a polynomial. So for this component, you want to make sure you take time to pause your video, create your chart, because we're going to fill this in with lots of good stuff that you're going to use throughout the entire chapter. So you'll want to have this guy kept handy with you. So go ahead and pause, and when you're ready, hit resume, and you can pick up where I'm leaving off. Sorry for the bell, guys. That means we'd normally be going to our 3rd period class. All right, so we're going to first start out with just a degree of 0. To be a degree of 0 means we have no variables. We just have a number. So for instance, 32. No number, just a number, no variable, sorry. No variable, degree of 0. When we have a degree of 0, it is called a constant. That means our value never changes. It will always be this number, 32. Or if that number was 4, or if that number was 8. But in our case, we're going to use 32. A degree of 1, which means now we're going to have a variable, and it's going to be raised to the 1st power. So for instance, we have, say, 3x plus 5. Here we have, remember, the degree of a polynomial is based on the sum of the exponents, and it has to be the highest one we see. So the very first one that we see, as long as it's in standard form, so our highest degree here is this monomial. And the understood exponent here is 1, so this makes this a degree of 1. Degree of 1 is called linear. And there is a math word in linear. Do you know what it is? Say it out loud at home. That's it. It is line. You see the word line in linear. So we were to graph this would look like a line. Then we're going to talk about a degree of 2. Degree of 2 now means our highest degree is 2. And then we can have other terms after that as well. But our highest degree is 2. And that degree is called a quadratic. Then we're going to talk about a degree of 3, which means our highest exponent that we see will be a 3. whether it's one monomial or a group of monomials, as long as the highest exponent we see or the highest sum of our exponents creates a 3. This makes it a degree of 3, which is called a cubic. We'll talk about a degree of 4. A degree of 4 has an exponent where the highest degree is 4. So here our highest degree is 4, going to 3, then to 2, then to 1, and then to no exponent whatsoever. So if our highest degree is 4, this is called a quartic. Think of a quartet. A quartet has 4 singers, so this is a quartet. So this is naming degrees. It's kind of like when you're born, your mom and dad give you names, and you have a first name and a last name. So the naming using the degree, this is your first name. Then we'll give them their last name based on the number of terms that we see. So our terms are separated by addition signs and subtraction signs. So looking at our first polynomial, 32, there are no adding and no subtracting signs. It is just a single number. That means it has one term. If you have just one term, it is called a monomial. Because monomial, think of mono is one, like a monologue. It means one person is saying it all by themselves. So monomial means one. In our second example, we have our 3x, and then we have a plus 5. So we have two monomials that are separated by one addition sign. So we have two terms. Two terms is a binomial. Bi means two. So think of like a bicycle has two wheels. So a binomial has two terms. Our third one we're going to talk about is our third polynomial. We have 3x squared, that's one term. We have 2x, which is two terms. And then we have the 3, which is three terms. So we have three terms. This is called a trinomial. Just like a tricycle has three wheels, or a triangle has three sides. Tri means three terms. Looking at our fourth example, we only have one term, 5x cubed. Since we only have one term, this is called a monomial. Because remember, one term is a monomial. Our last one has 1, 2, 3, 4, 5 terms. For this category, as long as we have 4 or more, it fits in the same category called a polynomial. And our guy over here had 5 terms. So 5 is 4 or more, so we have a polynomial. So we have two polynomials down here at the bottom, and they're not in the right order. So we got to write them in the correct order, and then we're going to name them. We're going to give them a first name and then a last name. So we're going to look at our first guy. We got to put him in the correct order first, which means we have to start with the highest degree. So our first monomial here has a degree of 1, and our second monomial here has a degree of 2. Since 2 is larger than 1, this monomial here will be written first, and you always use the sign that is to the left of it. This means this is a positive 4x squared. Then we got our 3x, and you're like, what sign do I put in there? Since there is no sign there, it is an understood plus, so an understood positive 3x. So now we're in standard form, highest degree being 2, lowest degree being 1, 2, then 1. If it is a degree of 2, we use our degrees, naming by degrees. Degree of 2 is a quadratic. And we now have to name by the number of terms to find our last name. So we have two monomials. So two monomials means two terms, making this a binomial, a quadratic binomial. Looking at our last example, we have to put them in order. But we notice here we have our highest exponent we see is a 3. So we'll start out with our 5x to the third. But when I look at this problem, this 4 has an x to the first, and this 7 has an x to the first. This means these guys are like terms. So I need to take this 4x and add 7x's to it. So 4x's plus 7x's make 11x's. So sometimes you must combine like terms. Then I have my leftover of a minus 1. Again, to name my guy, I need to first start off by using his first name, which is using the degree. So the highest degree we have is a 3. So I go to degree of 3 and look on my chart and see that that is a cubic. Then I need to find his last name by determining the number of terms. I have 1 term, 2 terms, 3 terms, meaning this is a trinomial. So what we are looking at is a cubic trinomial. We're going to move on to some practice time. So again, feel free to pause, rewind. That way you have plenty of time to review what you need to know. So we're going to take each of our examples and put them in order from highest exponent to lowest, combine any like terms if need be, and then name them based on their degree and number of terms. All right, so I'm going to explain this if you need to pause and give it a try. Hope you get them all correct. My highest exponent is a 7. The value in front is a negative, so this means I have a negative 3c to the 7. My second highest exponent is a 3, so, and I use the sign in front of it, which is a plus 8c to the third. Then I have my lowest exponent, which is a c. Since there is no sign in front, it's an understood positive c. So now I'm in order. 7, then 3, then 1. So that descends. 7, we don't have a specific name for a degree of 7, so we just say this is a 7th degree. So it doesn't have a special name, it's just 7th degree. And then we have 1, 2, we have 1, 2, 3 terms, making it a trinomial. For our second example, our highest degree that we see is 2. And we'll use the sign to the left of it, it means a positive x squared. Our next highest degree is 1, and we'll use the sign to the left of it, which means it's a minus 3x. And then we have our final one, which is a positive 4. Our highest degree is 2, which makes this a quadratic. And I have 1, 2, 3 terms, making it a trinomial. For our final one, I notice that I have 2 monomials that both have a degree of 2. So I've got to combine these first. So I've got 6 minus 13, which makes negative 7x squared. Then my next degree is a negative 4x, and then my final plus 4. This now is in the correct order. Since my highest degree is 2, this is a quadratic. And I have 1, 2, 3 terms, making it a trinomial. If you got all 3 of those right, give yourself a whoop whoop and a hop and a pat on the back. And that ends our first lesson of 8.1 Part A. Hope you guys have a great day and you did a fantastic job.